Well, hello there, and welcome back from break. We have a little bit of an interesting lesson tonight. It is a problem-solving lesson. It is lesson 5-6, and actually the name of the lesson is kind of its own little problem-solving. And so our problem-solving strategy that we're going to be attacking this time, this is our fifth one, starting all the way from the beginning of the year when we talked about how we are going to read all of our questions very carefully at least 3 times. We've talked about a lot of different problem-solving strategies. And so if you can figure this one out, that is the word working backwards. So that's our strategy today, working backwards. So let's dig right into an example problem so we can see what we're talking about here. And so imagine a real-world problem where you're going to go to a baseball game. And the baseball game is going to start at 1 o'clock in the afternoon. All right, and let's say this is, let's say you're staying in New York City and you've got to figure out how to ride the subway. And you know that the subway train ride is going to take at least 3/4 of an hour. And it's going to take you 10 minutes to walk to the train station. It says that in the first part of the question. The train rides 3/4 an hour, which is 45 minutes. And then once we get to the city, it's going to be another 10 minutes to walk to the stadium. So the question is, what time do we have to leave? Well, the best way to attack this problem is, like we just said, the strategy today is working backwards. So we want to get there by 1 o'clock p.m. All right? So let's start there and walk through all the things that are going to happen backwards and just figure out what time we have to leave. So if we want to get to the game by 1 o'clock, we'd better get off the train by 12:50 so we have 10 minutes to get to the game. Now, if we go back from that, the train ride was supposed to take 45 minutes, so that means that we need to get on the train by 12:05. And if we need 10 minutes to walk to the train station, let's take another 10 minutes away. And be a little careful here. That's going to back us up to 11:55. Now, you might be able to do that in your head, or you might use the idea of elapsed time. And so right here, we can't take 10 minutes away because we only have 5. So what we're going to do is we're going to borrow from the hour. Okay, so 12:05, if we borrow from the hour, we're getting a total of 60 minutes. Think about it, 1 hour is 60 minutes. So that's like 11 hours and 65 minutes. And now if I subtract 10, sure enough, I get 11:55. Now, all of this presumes that as soon as I get to the train station, there'll actually be a train waiting for me. So we might have to leave even a little bit earlier than 11:55, depending on what the train schedule is. But assuming that there is, the trains are running really regularly, if there's a 12:05 train, that'll get us to the city by 12:50 and then 10 minutes to the thing. Now, that's the absolute minimum. In reality, in real life, when we figure out a problem like this, we're going to build in a little bit of extra time for something that we didn't anticipate. But the answer to this question is if we leave at 11:55 a.m., very, very, very latest, we should still be able to make it to the game by 1 o'clock if nothing in the question changes. Now, before we go to the next slide, let's look at this information again. So again, remember it was 10 minutes from the train station to the stadium. It was 45 minutes on the train, and it was another 10 minutes to get from our house or where we're staying to the train station. So if we go backwards, let's take a look at another question. What if we have to be home by 6 p.m.? What is the latest the game could get over if it's going to take the exact same travel time to get back home? And again, that's probably unlikely considering crowds and things like that. But given the same estimations of 10 minutes between the train station and the stadium, the train station where we end up and home, and a 45-minute train ride or 3/4 of an hour, what time does the game have to be done, or what time do we have to leave the game, even if it isn't done, to get home by 6 p.m.? So go ahead and pause this video and work this problem backwards and see if you can find out what the time is going to be. And as soon as you've got an answer, go ahead and resume recording, and we'll go through it together, see if you get the same thing, and more importantly, see if you found it the same way. So go ahead and pause the video now and figure out what time we have to leave the ballpark. All right, welcome back. All right, so you should have done the same thing. We need to be home by 6 p.m. All right, so let's work backwards from home back to the stadium and figure out each of the time intervals. So if we want to be home by 6 o'clock, we'd better be off the train by 5:50. Right, because it was 10 minutes to get back to home from the train station. And it was 45 minutes on the train. So that means we'd better be getting on the train at 5:05. And once again, it's 10 minutes from the stadium to the train. So we had better be leaving the stadium at 4:55. Okay, now remember that game started at 1 o'clock, so we could actually have a game that is 3 hours and 55 minutes long. And I really should put an H there and an MI in there. And we should see the whole game. Even if the game goes into extra innings, though, we have to leave. If we're going to be back at 6, we have to leave by 4:55 p.m., and that'll give us enough time to get home. And so problems like this, especially involving time, are great problems to kind of start where we need to end up, and then one step at a time work backwards through the problem and work out our answer. Okay. Again, we still want to read the questions really carefully, and we want to read it one last time to make sure that things make sense. So in checking number 7 here, if I leave at 3:55, let's walk back. I'm sorry, if I leave at 4:55, let's walk back through, and sure enough, that gives me 10 minutes till 5:05, assuming there's a train right there waiting to take me. 45 minutes will take me to 5:50, and then 10 more minutes, and sure enough, I will arrive home in time for dinner at 6 p.m. Okay, so this is the strategy of working backwards, and so we're going to add this to our arsenal of problem-solving strategies. And tomorrow in class, we will go ahead and practice several of these, as well as reviewing all of our other problem-solving strategies, like we always do. So come ready to pick some good problems, and we'll be working on problem-solving tomorrow in class. So thanks for watching, and welcome back, everybody. And I will see you in class. Take care.